excited about the possibility of having an end-of-year test online. So I'm going to try and go through some of the things you should know about. This is not an exclusively complete list of everything you need to study, but it is a very good starting point for you. Okay, so I'm going to start off with diet, and you probably remember a little bit about it. Let me just choose my things. So here we go. So I've started off with the Eat Well plate, and as you know, there are some things you need for a balanced diet. Things like carbohydrates for energy, lipids for energy and insulation, protein for growth and repair, vitamins and minerals in small amounts to keep you healthy, water keeps you hydrated, and fibre stops you getting blocked up or constipated. You need to know what is in a balanced diet. You also need to know that the vitamins are quite important. So this is vitamin A, which you can get from tomatoes and fish and carrots and, I don't know what that is, a mango? And it's really good for your eyes. It helps make a substance called retinol. Retinol in your retina is really important. You might have heard of golden rice, which is a type of rice which has a gene genetically inserted into it that creates a substance called keratin, or beta-carotene, and you turn beta-carotene in your body into vitamin A. And it means that people who have a vitamin A deficiency will not go blind. That's massively important for them. So this type of rice, golden rice, is really important. It's given away for free so that farmers can grow it to help their countrymen and children. Another disease you might have heard about is scurvy, which is an insufficient amount of vitamin C. Scurvy is what pirates and sailors used to get because they didn't take many fresh vegetables with them. And it wasn't until the Navy started giving limes and lemons to their sailors that they started getting less scurvy on long trips. Scurvy is not very nice. It causes your cuts to open up again and you can't stop bleeding. You get sunken eyes, corkscrew hair, your teeth sometimes fall out. It's not a nice look. Next along the line is a disease called rickets. This is rickets just here. Rickets is caused by a lack of vitamin D. Now you get vitamin D by being in the sunlight naturally. Your body can make vitamin D by being in the sun. But if your skin can't get to the sunlight, then you get rickets. Now rickets normally only affects children because their bones are still growing. And because their bones are growing, they've got a chance for them to be the minerals inside them are insufficient to go for growth. So in countries which have a tradition of sending people down mines, the children were traditionally miners as well, they would get rickets because they were spending a lot of time out of sunlight. A good reason for getting a little bit of sun. Let's go on to the next slide and we'll see what's going on next. Now we go through your digestive tract. We've put all these foods in. So we go into your mouth, and you chew up, you do mastication, which means to chew, and you add saliva from the glands in your mouth, and they start to break down the food. It goes down your esophagus into your stomach. From your stomach, we add an enzyme which helps break down the proteins. From the stomach, we squirt out the food with its acid, and we neutralize it with bile from the gallbladder, which is made in the liver, and it goes into the small intestine. Now, the small intestine is really important. It's got these little villi, these are little finger-like projections called villi, and they increase the surface area so that you can absorb monomer food units. Monomers are the smallest bits. So if you took starch, you break it down into glucose, and glucose is a monomer that you can absorb through the thin walls of these villi. Because there's a big surface area, and because they've got thin walls, and because they've got a big blood supply which helps take the minerals which are absorbed and the nutrients which are absorbed away, it helps the villi do their job really well. After being in the small intestine, we go into the large intestine. Now the large intestine is mainly for trying to reabsorb some of the water that's in the waste products that you don't need anymore. If you don't reabsorb the water, then you're going to lose too much water and you can become dehydrated. Then you store it in your rectum and you eject the food through your anus. It's now called feces. Poo, if you want to use a non-technical term. On to the next slide. Now, You've heard as well that smoking isn't very good for you. There's some important substances you need to know about. So you need to know that carbon monoxide, this bonds with the red blood cells better than oxygen can, so you can't get enough oxygen around your body. Nicotine, as well as being a poison, it's also really, really addictive, and it makes you want to have more and more of the cigarettes or other smoking devices. One that's not mentioned here is tar. Tar is a sticky oil-like substance that causes the hairs in your lungs, which are there to clean out your lungs, it causes them to get stuck down and they can't remove stuff from the lungs. Now I've got this picture here. Apparently now in the UAE it is illegal to smoke in your car if a child is with you. So if you're a child and an adult is smoking with you, you can remind them that they should not be doing so. It's bad for people's health. Apparently smoking is still one of the biggest killers in the world. On to my fourth slide, which appears to be blank. I'm not sure why, but maybe we've gone to the fifth one. Here we go, on to plants for a little while, just make sure I haven't missed anything out. Oh yeah, I'm all doing well there. So, for plants, you need to know what they're like, particularly in the leaves. So I'm looking at the leaf here, it's a little cross section. This is the top of the leaf, this is the bottom of the leaf, and there are some important parts. So first of all, we need to get some oxygen out of the plant and carbon dioxide into the plant. That goes through a little gap in the bottom. It's called a stomata. Stomata are the hole. Around the hole are two guard cells that help open and close the stomata. From stomata, the carbon dioxide that's coming in, it's going to be used to do photosynthesis, goes into air spaces, and it permeates through the spongy mesophyll into these long cells here. I've got another view of them. These are the real ones under a microscope. These are called palisade cells. You can see, even though they're not in green, that they're packed with chloroplasts. And chloroplasts are the small organelles that help to do photosynthesis. They take the sun's energy from the top and the carbon dioxide from the bottom, and also some water, which is going to come through this vascular bundle over here. Let's click on here. This vascular tissue over here, and it combines them all to make sugars for the plant to go. Now I've also got a picture of a fence here. Now the reason I've got a picture of a fence, this is a palisade fence. It means spear fence because they look a bit like spears. These are called palisade cells because they are lined up a bit like spears as well. Kind of chubby spears, but nevertheless spears. So that's why we have palisade as their name. Let's go on to the next slide. Next, we've got states of matter. Now you have to remember that when we've got states of matter, we're not going to actually look much at how the atoms are arranged, but remember that we use a little s for solids, we use a lowercase l for liquids, we use a lowercase g for gas, and I'm not going to mention plasma, but I am going to mention a q, which is for aqueous, when things are dissolved in a liquid, normally water. And since we're on dissolving, I think we should know our S words here. So if we start with a solute, that's the thing that dissolves. And a solvent is the thing that dissolves it. So here I've got my solute and my solvent. When they dissolve, which is to pull the solute apart and surround it with a solvent, then you make a solution. That's the mixture of them together. As my solution is formed when a substance dissolves in it. Now, if it can dissolve, we say it's soluble. If a lot of it is dissolved and no more will dissolve, in fact, that's not true. If no more will dissolve, it doesn't have to be a lot, it could be just a little amount, then we say it's saturated. And if none will dissolve, then we say it's insoluble. So we need to know those key words, okay? Next, as we go on, we click over here, we need to know how we could separate things out as well. So let's start off in the middle. Now this is a filter. You can see I've got my filter paper and I've poured in a mixture of a liquid and something that's insoluble in it. And as it goes through, the stuff that goes through is called filtrate, and the stuff gets stuck is called residue. So the residue stays in the filter because its particles are too big to pass through the holes that are in the filter. The next one is called distillation. Now, distillation is very useful when we're not talking about a solid that could easily be filtered, but we're talking about two liquids or even two gases. Now, because different substances have different boiling points, you can use that fact to separate them out. So if I had a mixture of propanol, which is the alcohol that's found in nail varnish, and I mix it with water, I know that propanol's got a lower boiling point than water. So as I heat up the bottom, this container, my mixture, the propanol will evaporate, with my particles going up, and then they'll start to pass through this long tube. Now, to speed up the transition from a gas back down to a liquid, we can actually cool it down using this Liebig condenser. So you put cold water in the bottom, and it runs over the tube that's running through the middle, and the cold water comes out slightly warmer, but it's taken the energy away from that gas, so the gas turns from a gas, it condenses into a liquid and drips off into this little conical flask that's sitting at the bottom. The third way that I've got to separate things out is called chromatography. And we did chromatography using coloured inks, and they've done something similar here. So we've got a solvent at the bottom, and we've got our samples, which are the mixtures of different substances that we want to separate. And you can see that they've tried 1, 2, 3, 4, 5 different substances. Now, as the liquid soaks, as the solvent soaks up the paper, it dissolves some of the substances, the solutes, there's a little letters here, more than others, more easily than others. So you can see that the green substance here is just made up of one colour at the moment, as there's only green in slime, and it's only travelled this far. There's another sample of green here. So we know that sample 3 over here has green in it. We can see that the purple for this one here has gone a bit further than the green, over twice as far, and that sample 3 has got purple as well. The yellow sample over here has travelled further than the purple, and you can see that sample 3 has also got the yellow in it. And you can see that the red has travelled furthest, and that sample 3 has also got red in it. So we know that this greyish-black ink at the start was really made up of green, purple, yellow and red. And they've separated it out, so we can use that to work out what substances are present. To the next slide. Oh, your friend the periodic table. I want to talk about a few different bits in here. Now, first of all, we need to know that from our BCST everything on the left is a metal. So remember, BCST I don't know if it goes that way or if it goes that way. We'll find out at some stage. They're all metals. These are all non-metals. And over on the left-hand side, things get more reactive as you go down. That's why I've got this big arrow here. And you might remember that we looked at lithium, and we looked at sodium, and we looked at potassium when they reacted with water and how hard they were. So lithium was quite hard, sodium was softer, and potassium was really soft. And lithium reacted a bit, it fizzed. Sodium caught fire if I put it on a piece of paper, and potassium caught fire without the piece of paper when I put it in the water. So it gets more reactive as it goes down in that order. You might remember as well some of the other ones, things like my zip is cork, that's for magnesium, and then zinc, and then iron and copper. Now that order doesn't work quite so well, so it's not just going downwards, but magnesium, these ones here are more reactive than these ones here. And these ones in red are more reactive than the ones in orange next to them. Okay. What else do we need to know about the periodic table? Well, you probably want to know a little bit about where things like iron, cobalt, and nickel are, because these three have got an interesting property that we'll look at in a bit more detail later, that they're all magnetic materials. These ones can become attracted to magnets. And as a result, most magnets are made out of them. Let's move on to my next slide. We might come back to the periodic table later. For all those metals, all 84 of them, they've got some properties which we need to know. First of all, they're lustrous. Lustrous means they shine, they have luster. They're good conductors. They're good conductors of electricity and heat. They tend to have a high melting point and a high boiling point. And that means that when you heat them up, they stay a solid for a long time before they become a liquid. And when you're cooling them down, they quickly go from a liquid to being a solid. It's not true for all of them. Let's think. Mercury is a liquid at room temperature, and gallium melts at body temperature, but most of them have a high melting point. They tend to have a high density, which means that for the amount of space they take up, they seem heavy. They tend to be malleable, which means you can change their shape, and we also say that they can be beaten into sheets. And they are ductile. That means if you pull on them, they can be stretched into wires, a bit like a piece of chewing gum. Chewing gum is also ductile. It's not made of metal. They're opaque when they're in thin sheets, so you can't see through them. And the last one is they're sonorous. Sonorous means they make a ringing sound when you hit them. Sound like a bell. Non-metals, on the other hand, are dull, poor conductors. They tend to be non-ductile, they tend to be brittle. They can be solids, liquids, or gases at room temperature, and they can be transparent when they're a thin sheet, and they are not sonorous normally. There are some exceptions. Okay, on to the next slide, number 10. We need to know a couple of reactions, and we've seen these before. I just mentioned one of them. Metal and water, if they react together, then you make a metal hydroxide and hydrogen. Remember this. Let's think of an example. So if we had lithium plus water, we make lithium hydroxide and hydrogen. If we had magnesium and water, we'd make magnesium hydroxide and water. If we had francium and water, which would be very unlikely, we'd end up with francium hydroxide and hydrogen. So it's the same rule every time. If you react metals with oxygen, they make a metal oxide. So if you had iron and oxygen, you end up with iron oxide, which we know as rust. Or you had sodium and oxygen, you get sodium oxide. If we had potassium and oxygen, you get potassium oxide. So it's the same routine each time. And since I had a little bit of space, and I'm talking about hydrogen gas here, you should remember the test for hydrogen gas. Now, if you take hydrogen gas and you put a lip splint in it, it makes a squeaky pop. That's the sound that we get when it's working. Sometimes it doesn't work, and there's a couple of reasons why it just catches fire. It can be the concentration, the ratio of oxygen to hydrogen sometimes makes it not pop so well. And I found out this weekend that the reason it pops is because of impurities in the hydrogen gas. So if you've got a really pure sample, you might not get a pop as well. Next one. Magnetism. Okay, so we've seen the field lines going between magnets. There's a nice horseshoe magnet and a bar magnet. You can see the magnetic force lines are trying to go all the way around from north to south, north seeking to south seeking. And you can imagine that they're actually going through the middle as well, so north seeking to south seeking. And we did it with little magnets. They were little magnets, little compasses. So the south seeking end points at the north, and we did it so we could draw around from one end to the other, like that as well. When you've got a north and a south pole facing each other, they try to go from north south, and they attract each other. If though you've got a north and north pole together, the magnetic field lines you can see are actually trying to push away from each other, and the magnets will push away from each other as well. And the same thing happens if you have the south and the south ends facing each other. Because they're trying to attract the north end, they're actually trying to repel, they're trying to repel the same pole. So if it's the same pole, they repel. Slide number 12. Static electricity. Now, I'm sure you've all been in a situation, I know I have, where I've woken up or gone down a plastic slide and my hair is stuck up just like this, exactly the same. And that's because of static electricity. Now, static electricity happens when you build up a greater amount of charge of electrons in one place. So here we've got a balloon and it's being rubbed against something to give it lots of negative charges. Now the negative charges push away charges that are the same. So we can see the negative charges here pushed away from them, and they've actually attracted the positive charges. So the positive, actually they haven't attracted, they've left the positive charges. So now things are going to be attracted. And if you had two balloons, both covered in negative charges, because they're the same, they actually want to push away from each other. And that's exactly what's happening with these hairs. So this hair here and the one next to it, if they're both covered in negative charges, they try and push away from each other as far as possible, so that the hair ends up spread out. You can use this to pick up small bits of paper or pepper at home. So if you rub your plastic pen and coat it with negative electrons, it depends what you rub it on. If you rub it on something that's nylon or polyester or wool, you'll get different results. And then you can bring it close to some small bits of paper on your table, and they will jump up. We did something similar with the Van de Graaff generator to show the same effect without having to rub it on our jumpers. Now, from static electricity, we can jump quite happily into regular circuits. So on the left, I've got a circuit which just goes around in a single loop. So we call it a series circuit. Okay? This one's got an open switch. Because it's open, the electrons can't move around the circuit. There's a big gap. So we have to close the switch for them to allow the current to flow. And when the current flows, the light bulb lights up. On the right, I've got another type of circuit. This one's got a parallel circuit, which means it's got more than one route that the electricity, so the electrons, can flow through. So it goes around like that, or it goes around like this. It doesn't go around like this, because there's no push to force it to go up. So you have to use the cell here, the batteries, made of little cells, to push the electrons around. Now the circuit symbol for this looks similar. And you can imagine that if all the electrons are going around like this in the current, then half of them are going this way, and half of them are going this way, roughly. And then they rejoin up, so you get half and half to get them back to the same amount. That means that we're splitting the current. So if you had a current of 1 here, you're going to get a current of 0.5, like it fast enough here, and a current of 0.5 here, which will then add up back to 1 again over here. So the current gets split. Okay, I hope this has helped a little bit. If you want to watch any of the pieces again, this is a video, you can go back. If I'm talking too fast, you can slow down the playback speed, and you should make sure you make notes on each of those things. I've also made a quizzes. Now your quizzes is amazingly long. I hope you enjoy doing it. I've based the questions on things that you should study. Try your best to get 100%. Okay? If you do get 100% and you've used your own name, so I know who you are, I will give you a house point. Okay? Have a great revision session. Speak to you soon. Cheerio. Bye-bye.